All right, so we got Dave here, and he is going to describe his Coriolis meter to us, and also how he writes custom software. Take it away, Dave.
Yeah, so this Coriolis meter, this is a 1.5 or 1 inch triclover fitting. The flow goes this way, and the flow can go either way, but that's the classical direction of Coriolis meters for some unknown reason. And what it does, it has 2 oscillating tubes in here that are set into resonant frequency, and F equals the square root of K over M. You can determine
The spring constant.
the spring constant. And what this does is, the way the Coriolis meter works, envision holding a hose of water hose. Shake it up and down with no water flowing in it. And it'll just shake up and down and just up and down. If you start turning flow, there will be a phase shift between the inlet and the outlet that's proportional to the flow rate, the mass flow rate of the fluid going through that pipe. So that's in essence how these things work. I mean, there's lots of videos showing how they work, but I'm giving you the simple water hose that you could do at your house.
So we have a water hose. We start shaking it up and down.
The U of it, you
Yeah.
take apart into a U and you shake it like that, and it'll actually feel like it's twisting a little bit. This has a very rigid structure here, and the tubes are welded, and then there's coils and sensors that measure the displacement here, and then sensors up here that measure the twist of the 2 tubes as they're.
And the more water, the more it twists.
Yes.
And we measure that twisting really, really accurately.
We can measure that twist by the phase angle difference between this one and this one. So we're measuring a phase angle difference.
So by twist, it's the phase.
Yeah, it's a phase shift. And so inside, the electronics does all that magic stuff. Now I'll show you what we do generally for universities and such. Is they'll say we need a flow meter to do this.
We'll move over here.
So this university said, we need to do this. We need to measure the temperature, the flow, and the density. And we provide, this flow meter can measure all those variables. So we just put together a screen, give them lab view, so they can go do what they have to do. They may hook up a camera here, pressure sensors, and instrument this, but we give them this part so they have a head start to get what they need to do in their system done.
So just to kind of back up on this, essentially we have people that need to change what the flow meter says.
That's right.
On the outputs. So just go back to here. These outputs might need to be something different. That's a little bit complicated, and Dave can go through and he can write some LabVIEW software to figure out how to make sure that the flow meter has the right outputs for your application.
And the registers that they can look at, here are the registers that this register value is the flow rate, 168 in kilograms per second, the density, the temperature. So we tell them how to do it, and they'll generally go, I'm not quite sure how to do it in LabVIEW, because the universities use LabVIEW and instrument. And so will you give us a head start, and we'll say, here you go. And in the back of this program, they can see the answer. Let's see if I'm gonna stop it and look at the back side real quick. Control E. And
so this is the actual LabVIEW code?
Yeah, this is the code we'll give them and let them do what they gotta do. Here's single variable and graphs. And people who know LabVIEW know what all this stuff does. And then they'll do it. Oh, thank God, I didn't know I needed to do this, this, and this, and this. And now I see I could put any register I want. Here's a register, any baud rate.
And you can just display whatever information you want on your flow meter.
Yeah.
And this is a common need of clients in the industry.
Yeah.
And we're the only people that can write custom LabVIEW code for.
Well, only people are silly enough to do it. But we'll give them a hand. We don't consider this secret stuff. This is something we're honored that you would use our flow meter. Here's some head start.
And can you give me another example of a change that they might want to have? Because right now we have flow mass.
Yeah, this one is through the glass, so I can go and and look, so I could look at all variables of this thing. But they want to know, they want to read what this is reading. This reads flow, it reads the total, like odometer and speedometer, and reads the density and the temperature. How cool is that?
And other clients might want to have different things on the display, and you use LabVIEW to change what its output is.
No, they usually want just those 3 or 4 variables, and they want to grab them for whatever purpose.
Okay.
And maybe you are making some kind of a granola, and you care about the density of the syrup you're using, and you have 2 lines coming into some kind of syrup A and water, and you mix it so that it creates the proper density. This can be the density measuring machine that's used in the control loop that says, oh, I need to put a little more water because it's too dense.
So in that instance, you're going to write some custom LabVIEW code to turn this into a density measuring machine.
It is a density measuring machine for free. It's already there. It measures density.
It just needs the software upgrade.
Not an upgrade.
I mean,
Yeah,
I know.
you just need to know what's the density is register 170. Boom, there it is.
Cool. Thanks, Dave.
Yeah, simple machine.